Hello friends, so we are going to continue our session on centroid of given area. So let's solve another problem based on centroid of given area, and here we have to find the centroid of shaded area. So they have given area to us friends over here, you can see. So we have to find the centroid of shaded area formed by a straight line y equal to mx. So there's a straight line over here friends, you can see y equal to mx, and a curve y equal to kx square. So this is the curve y equal to kx square. So by using integration method, we need to find out the centroid of this particular area, which is bounded by a straight line and a curve. So let me start with the solution part friends. So this particular problem consists of two different sections. That is, suppose you take centroid somewhere here. So let's say this is a centroid. So centroid is going to have x coordinate and y coordinate. So it is going to have x coordinate, let us say x bar, and the y coordinate as y bar friends. We are going to solve for x coordinate first, and then we'll go for the y coordinate. So the first part is to find x coordinate of centroid. To find x coordinate of centroid, we will take a strip. So we are going to take a strip which is a vertical strip, something like this friends. A very thin strip. Let's say this is a very thin strip here. A vertical thin strip. So the thickness of this strip is going to be very small. I can say thickness of this vertical strip is I'm going to take as dx over here friends. So this thickness is I'm taking as dx. Infinite decimally small thickness dx. And the distance of this thin strip from the y-axis, that is this distance friends, this distance I'm taking as x. Okay, so the distance of this particular thin strip is going to be x from the y-axis, and the thickness of the strip is dx. Now we need to find the area of thin strip. That is very important. The area of thin strip is given by the height of the strip into the thickness of the strip. So if you see the height of the strip friends, so if you look at this particular point on the boundary of the area, that is y equal to kx square. So the height of this is going to be, this height is going to be, we can say, let's say y equal to kx square. This height has come from the equation of this curve. And if I take this particular point, so friend, this side is given by this equation, which is the straight line, that is y equal to mx. So the difference between these 2 points, if I say this is y1 and this is y2, so the difference between these 2 points will give us the height of the strip friends. Okay, so we got height of the strip and we got the thickness of strip, so we can find out the area of thin strip. Considering a thin vertical strip of thickness dx at distance x from y-axis. That's very simple. We've understood that. So the area of the thin strip is given by, therefore, area of thin strip, that is infinite decimally small area of thin strip is written as dA. So from here to here, height is friends mx, y equal to mx. So it is going to be m times x minus this height is kx square. So this is going to be the height friends times thickness. The thickness is nothing but dx. The thickness over here you got dx friends. So thickness is dx here. So this is the area of thin strip. Now how to get the x coordinate of the centroid? So x coordinate of centroid, so the x coordinate of centroid is given by a very simple expression that already I have explained in the previous classes. You can just refer those videos. So the x coordinate, that is x bar, is given as integration of x times dA, that is area of the thin strip, divided by integration of dA. So now let me put those values here. So we got x as it is. So integration will be as it is. Then we'll have x times dA. dA is this value friends, m into x minus k x square, divided by, again area is here, dA. So again integration of area, that is mx. Over here dx is also there. dx part has to come. Similarly, denominator will have only area, mx minus k x square. This value I'm writing into dx. Now the important thing is the limit. So if you see here, the variable is x. So x has a limit from here at this particular point, x equal to 0 friends, and this strip is going to start from here and it is going up to the tip of the area. So at this particular point I can say here the value of x is going to be this, right? That is x coordinate of the tip. So if you look at this extreme point, we can say at this particular point x is going to be a. So x is going to be a. So we are going to start from x equal to 0. This vertical strip is going to start from this particular end, that is x equal to 0, and it is going to proceed all the way up to this particular point, that is tip of this area, that is point A, and here we have x equal to a. So x equal to 0 to x equal to a. So limits will be x equal to 0, x equal to a, here also 0 to a. So we need to integrate this in order to find the x coordinate. Let's see, can we integrate this, or it is difficult to integrate? No, it's very simple to integrate. Just follow simple procedure. Before going for the integration, let me simplify the numerator part. So x can be multiplied into the terms inside the bracket. So x into mx is going to be mx square, integration 0 to a mx square. Now this x will also multiplied here, so k times x cube dx. Again denominator 0 to a, denominator I'll keep it as it is, friends. So that is mx minus kx square times dx. Now the integration of mx square is going to be mx raised to 3 by 3. So it is going to be mx cube by 3. Integration of kx cube is going to be kx raised to 4 by 4. The limit is 0 to a whole divided by, now let's do the integration part in the denominator. So when we do the integration in the denominator, the integration of mx is going to be mx square by 2 minus kx cube by 3, 0 to a. So we have done the basic integration of it. Now we are going to put the limit. So when you put the limit, friends, the upper limit is a while the lower limit is 0. So 0 will not count because all terms contain x over here. So when you put the limit, the terms get simplified, friends. So it is going to be something like this: m a cube by 3 minus k a raised to 4 by 4. Here m a raised to 2 by 2, and then we'll have k a raised to 3 by 3. Very simple outcome, you can see. Now if you want to simplify this equation, I need to get the value of m and k. So if you look at this straight line and this curve, right? So at this particular point, both the straight line and curve are meeting. So this point is going to satisfy straight line as well as the curve y equal to kx square. So if I put x equal to a, y equal to b over here, I'll get the expression of m. And if I put x equal to a, b equal to y over here, I'll get value of k from this expression. So let us put that. So if we substitute x equal to a and y equal to b in the straight line equation, what I'm saying, y equal to mx, friends. So we get out of it the y equal to b and x equal to a. So we'll get m equal to b by a. Very simple outcome. And if you substitute same thing in equation of curve y equal to kx square, y equal to kx square, so you get the value of k as, again friends, y is b, so b, and x is a, so b by a square, right? So, by simple substitution we are able to get the value of m and k. This value can be substituted over here to get the value of x coordinate of centroid. So let us do it, friends. So when you substitute that value, we'll get x bar as, let's see, so m is basically b by a here. So let me put it up. So b over a, then a cube by 3 as it is. Let's see what you get. A cube by 3 minus k is b by a square. So it is b by a square, friends, into a raised to 4 divided by, or over here we have got 4, friends. So 4, and that if I divide whole thing by, again m is again b by a, friends, a square by 2 minus here k, so b square by a. So here again you see k is there, so k is there, so k is b by a square. So let me put value of k as b by a square times a cube by 3. So if you look at here, friends, this is going to be from a cube, we can cancel out 1a, so it will be going to be a square. So this will be a square, friends. Now a square cancel out, so it is going to be again a square. So if you look at here, b a square by 3 and then b a square by 4. So what we are getting is interesting. Here also if you see, a cancels out, so b a by 2, and here only a is remaining. If I write down again, you will be getting b a square by 3 minus b a square by 4 whole divided by, that is a is pending over here, so b into a, so b into a by 2 minus again b into a by 3, b into a by 3. And if I simplify this, friends, this is going to be b a square by 12, and this is going to be b times a by 6. And if I simplify it, I can see here b gets cancelled out, 1a gets cancelled out, friends, so we'll get only a, and this is going to be 6 2s are 12. So the value is going to be a by 2. The value is going to be, friends, a by 2. So this value will be a by 2. So you can easily get the value of x coordinate of centroid as a by 2. Simple calculation, and you can find out this value. This is nothing but a by 2. X coordinate is a by 2. We have completed here the part 1. We have got the value of x coordinate of centroid. Now we are going to do the part 2, that is y coordinate of centroid. Okay, so let's see how to proceed for that. So friends, now we will calculate the y coordinate of centroid. In the part 2, friends, we'll calculate y coordinate of centroid. So here we can say that we have got centroid somewhere here. So it will have x coordinate as well as y coordinate. So now we are interested to find out the y coordinate of centroid. So to find the y coordinate of centroid, we take a horizontal strip like this. We consider a horizontal strip of a very small thickness. Let's say this is the horizontal strip, and this strip has got a very small thickness like this. Okay friends, so we can say this is a horizontal strip, and the distance of the strip from x-axis, we'll say like this, we take it as y. The thickness of the strip is very small, and that is called as dy. This thickness we call as dy, friends. Okay, so we need to find out the y coordinate by considering a horizontal strip of thickness dy. So the calculus is very simple, friends. The y coordinate of centroid, that is y bar, is given by integration of y dA. dA is the area of thin strip divided by integration of dA. So whatever thin strip we have taken, this one, it has got a very small area. The area of this thin strip is dA, infinite decimally small. Okay, now we want to find the area of thin strip. So now we need to find the area of thin strip, that is dA. So the area of thin strip will be given by the length of the strip into the thickness of strip. Okay, so the length of the strip is nothing but the difference of x coordinate here and here. Between these 2 points, the difference of x coordinate will give us the length of the strip. So over here, the value of x will be at this particular point. If I say from here till here, the value of x is going to be from this particular expression. So we'll get x equal to y by m, and at this particular point, if I say I want to find the value of x coordinate, so from here to here, the value of x coordinate would be, friends, given by this equation, which is y equal to kx square. So if I get value of x from here, y by k equal to x square, so x will be square root of y by k. So here the value of x will be, friends, square root of y over square root of k. So the difference of these two the difference of these two x coordinates will give you the length of this strip, and the thickness is dy. So I can simply find out the area of thin strip as, so I'll write down here, area y will be as it is, and the area of thin strip is x over here is square root of y over square root of k minus x over here is y over m times dy. The same area is going to come in the denominator, that is square root of y over square root of k minus y by m dy. Now the variable is y over here, friends. So the y in this particular shaded portion is going to vary from this point to this particular point. Up to here it is going to vary, friends. The value of y is going to vary. Over here y equal to 0, I can say this is y equal to 0. Over here y is equal to 0, and over here y equal to b. So our limit of integration will be 0 to b for this numerator as well as denominator. So limit of integration will be from y equal to 0 to y equal to b. So I'm going to put y equal to 0 over here and y equal to b over here, 0 to b. Now let's simplify this expression before integrating it. So y bar is going to be 0 to b. Y gets multiplied inside, so you'll get y raised to 3 by 2 over root k, and over here we'll get y square divided by m. This is the numerator we got, friends, and there will be dy also over here. Now similarly, we'll try to get denominator. Denominator is simple, 0 to b, and here we have y raised to 1 by 2 divided by root k minus y over m dy. Very simple. Now let's integrate this. So integration of y raised to 3 by 2 is going to be y raised to 5 by 2 over 5 by 2. So you'll be getting y raised to 5 by 2 divided by 5 by 2, and then there's a root k as it is a constant here. This is going to be y raised to 3 over 3, m is there, no problem, as it is, 0 to b. Here we'll have y raised to 3 by 2 over 3 by 2, root k will be as it is, and here we'll have y square by 2, and m is there as it is, limit 0 to b, friends. So now we need to simplify this. So let's apply the limit of integration from 0 to b, and let's see what you get here. So y bar is going to be, I'm going to put upper limit b over here, so b raised to 5 by 2, this 2 by 5 will go up, so we'll get 2 by 5 root k root, and the numerator will be having b raised to 5 by 2. So b raised to 5 by 2. I have put the upper limit minus here b raised to 3 divided by 3m. This is numerator. In the denominator, what we'll get, that is interesting. 2 will go up, 2 by 3 here, b raised to 3 by 2 over root k, and here b square by 2m. Previously we have got the expression of k as well as m, friends. So we got previously m equal to b by a and k equal to b by a square. I'm going to use these two expressions over here so that we can simplify it further. So let's see what we can write down here, friends. So I'll be getting, so here if you see this, I'm going to simplify. It is going to be 2 by 5 b raised to 2 times b raised to 1 by 2. Pi by 2 is b raised to 2, b raised to 1 by 2. And root k is here, friends. So root k is nothing but, if you see here, root b over root a square. So it is going to be root b over a square. I'm substituting the value of k over here. Minus, now here b cube is there, divided by 3m. The value of m is b by a. I'm going to put b by a here, straightforward. Again 2 by 3, friends, denominator here. I'm going to simplify this. This is going to be raised to 1 times b raised to 1 by 2. Just for simplicity, I'm writing all this. Root k is nothing but square root of b by a square minus b square over 2m. 2m is nothing but b by a. Now we have to see a very simple. So let's simplify this, friends. So when you simplify this, you'll realize that here we have got 1b. So this will cancel out. We'll get b square here. Here we got 1b. So get cancel out. Only b will be there. Now this, if you see, this is nothing but b raised to 1 by 2 by a. This is b raised to 1 by 2a. So this whole thing is nothing but, if I write this, friend, this is b raised to 1 by 2 divided by a, because a square and root is there, get cancel out. So now, so this is also, I can write b raised to 1 by 2 in the numerator, square root is there, divided by square root of a square is a only. The entire thing would get simplified, friends. So let me write down how you get. If you write this, it will be 2 by 5 as it is. This is b square, b raised to 1 by 2. In denominator, we have b raised to 1 by 2 over a minus. Now here b square by, if you see here, this is b square and 3 by a. So a will go up, so we'll get b square a by denominator also, you see here, friends. This also will be b into b raised to 1 by 2, 2 by 3, b into b raised to 1 by 2. In denominator, we'll have again, friends, b raised to 1 by 2 divided by a. Okay, and here if you see, b square got cancelled out, so only b was there, and by a, so you'll get ab by 2. Very simple algebra, you can do it. Okay, once you see, you can easily do it. If you see here, friends, this b raised to 1 by 2 here, and you're getting cancelled out, a will go up, so ab will be there, b raised to 1 by 2 getting cancelled out, a will go in the numerator, so b square a, b square a. This is nothing but 2b square a by 5, and this is b square a by 3, and this is going to be 2ba by 3 and ab by 2. If I simplify this, value of y bar will be, friends, I write it here, 2 by 5 b square a, 2b square a by 5 minus b square a by 3, this whole divided by, let's see what we have here, 2 by 3 2ba by 3 minus ab by 2. That's very simple outcome. Now if you simplify this is going to be 3 to the 6 minus 5, so 6 minus 5 is going to be 1, so b square a by 15, this is going to be b square a by 15, and 2 to the 4 and 3 ones are 3, so 4 minus 3 is 1, so 1 ab by 6, so I can say ab by 6, and that if you further simplify, friends, you can easily get this 2 times b by 5. This is the value of y coordinate of centroid, friends. You'll be getting y bar as 2 by 5 b. So if you follow this simple procedure, you can easily find out the x and y coordinate of centroid for this region, which is bounded by a straight line y equal to mx and a curve y equal to kx square, and the both are intersecting at point a comma b. The same procedure you can follow for similar kind of problem. Thank you very much.